Hello everyone, welcome to this video on machine learning. Now in this particular video we'll be talking about very important algorithm, that is linear regression. Now linear regression is one of those algorithm that we take as a starter point, that any beginner can take as a starter algorithm for getting its hands on in machine learning. We will be trying to solve a very important problem and very popular problem of machine learning, that is predicting the house prices using linear regression. So first we will try to understand what exactly is linear regression. Then we will understand how the data of predicting house looks like, and then we'll try to get the intuition behind solving it. So first let's start our discussion with linear regression. See, linear regression is a very good supervised learning algorithm, a very basic one, very intuitive, I would say. And linear regression basically tries to get the relationship between the dependent variable and one or more independent variable. Okay. Now, if there are only one independent variable, okay, first let me tell you what is dependent and independent, if some of you don't know that. So see, this is the data, okay, that we are going to work with, housing price data. Okay, this is what we need to work with. Now here we need to predict this particular feature, that is price. Okay, so we need to predict the price feature. So basically the price feature depend upon these features: year built, location, number of rooms, and area. So all these four features that we have here, okay, are independent features, are independent because they are independent of any other feature. But this price feature, since we need to predict it, so this price actually depends upon all these features, all these four features. So this is called as dependent feature. Okay, so there can be more than one independent feature, and you can see here we have one dependent feature with us. Now why price is dependent? Like house price, it depends upon how much area your house has and how many rooms your house has, what is the location of your house, and when your house was being constructed, or when your society was constructed. So that's why the price of a particular house or a particular flat depends upon all these factors. Now there can be more features, more factors, but for an example, just to take a scenario, we have taken these four features. Okay, so this is what an independent feature is, and this is what a dependent feature. Now if we try to predict the house price, if we try to predict any particular feature, okay, using linear regression, okay, if the independent feature, if there are independent feature is only one, okay, if there is only one independent feature that we use to predict the house price or to predict any feature value, right, it is called simple linear regression. The algorithm is simple linear regression. But if there are more than one features, we call it multiple linear regression or multilinear regression. Some books call it different in the different names. Now what do we do in linear regression? How we predict the price of a particular, or how we predict the feature, okay, and how we forecast it. Okay, let's try to understand that. See, these green that you can see are the data points. These green dots are nothing but data points, the data values, right? For example, in this is one of the data point, this is another data point, another data point. So there are total 5 data points that we have in this data set. Now we have considered only two features. We'll be considering only two features because we'll be exploring simple linear regression and understanding its intuition right now. So the feature that we have considered are area and the price, right? So we will be predicting the price using only one feature, that is area. Okay, so let's say on the x-axis we have area, on y-axis we have the price. Okay, so all these are the data points that we have, the data set that we have. Okay, now the red line that you can see, the red straight line that is changing its slope, that is changing its intercept, is basically the ML model, is basically the linear regression model or linear regression line that we want to get. Okay, now what do we get, how do we get this line is the most important question that we'll try to explore. Okay, first, how do we get this particular line? See, you can see that this line is revolving. Like you can see this line is changing its slope, this line is changing its intercept. So if I show you the line equation, it looks something like this. A general linear equation, a line equation you must have studied in your +2, in your, or maybe in your bachelor's, that a simple line equation looks like this. Okay, it's y equals to mx plus c, where m here is the slope of the line and c here is the intercept of the line. Okay, now this is slope and this is intercept. So basically in any particular straight line we need to find its slope and intercept. If we got these two, we have got the line. Okay, so the line here is changing its slope, it's changing its intercept. That's what we need to find. Now how do we select whether this line is perfect or this line is perfect or this line is perfect? We have to find a solution for that, and that's where MSE comes into the picture. MSE is nothing but mean squared error. Mean squared error. Now what is mean square error? Let's try to see. See, for this particular x, okay, let's call this as x1. Okay, I'm getting a y, right? This is my y that I'm getting, this is the y value, this is the price that I'm getting. Okay, so this price, this is the price, let's call it as y1. Okay, this is some dependent and some independent feature. For us, we can consider area and price respectively, but yeah, let's call it as x1 and y1. Okay, so basically the coordinates of this point is x1 comma y1. Okay, this is what it has. Now this y1, okay, this y1 is actually the y actual. This is the actual value of y, because this is the data point that is given, the data that has been given to us, right? So we have been given this value, we have been given the x1, that is the area in our case, and we have been given y1, that is the price, the actual price of the house. Okay, but let's say we need to find out the price for some other area, right? That's why we are building the machine learning model. Okay, now just to give you an example, let's say for x1, this particular value would be y predicted, because this particular value, this particular point lies on this machine learning model, this machine learning ML line, right, or linear regression line. Okay, because every point on this linear regression line will give us the predicted value for a corresponding x. Okay, so for this particular x1, this is the predicted value that we have got. If you try to label it on the y-axis, this is what we have. This is y1 cap, let's call it as y1 cap. This is basically the predicted value of this particular x1. Okay, so y1 cap is nothing but the predicted price, you can say the predicted price by our machine learning model. Okay, so we have got the actual price, we have got the predicted price, we have got the area, that is x1. So we have three things, x1, y1 and y1 cap. Now you see that there is a difference between the actual price and the predicted price. This is the difference that we have, and we call this value as error. We call this value as error. So this is for one point, this is for only point x1, right? If you see for this particular point, if you see for this particular x, okay, there is again some error that will come. Okay, so for this point, this is the error. For this point, this will be the last error, right? So all these errors, okay, is what we need to minimize. So any machine learning model, any machine learning linear regression line, this particular line I'm talking about, whichever line gives the minimum error for all the data points, okay, we will select that line. That would be called as best fit line, because that is fitting the data at the best possible level. That will call as best fit line. Okay, so that line we will select. Now how we will calculate this error? We will subtract the y1 with y1 cap and we will square it, because this error can be positive, this error can be positive and negative depending upon the location of the data point. So we will square it and we will add for all the data points. You can see there is a summation that I have added from 1 to n, that is covering all the data points. So this is the value of mean square error, and when for a particular line which has the mean square error value as minimum, we will select that particular line and we will proceed with that model, we'll proceed with that linear regression line. Now let's try to understand it from our example as well. See, here I have taken the price on the y-axis and area on the x-axis, and this is the linear regression line or the best fit model that we have got. Okay, that we have created by selecting the error. The MSE error comes out to be 140 by doing the calculation that we have, and we have got this best fit line. Okay, you can see this is the best fit line and this X is actually the data points that we have. Now you can see this is the error value that we actually have, right? So if you say that this, let's say this is actually y1, so y1 here is 450, right? And for this y1 cap would be somewhere around 425, let's say 425. And now when we calculate the MAC error, okay, what I will do, I will say 450 minus 425 whole square plus this value, this error, plus this error, plus this error. Now for this the error value would be 0, right? For this the error contribution for this data point would be 0 because this data point lies on the model itself, on the linear regression line itself, right? So for this y1 cap minus y1 would be 0. Okay, so similarly we will add on all these small errors and we'll try to calculate the summation that we call as MAC error. And once we have got the MAC error, we'll try to minimize this MAC error and get the model done. Okay, so that was the intuition behind the linear regression, and that is how we can solve this very important problem of house price prediction. Now this is just the one feature. We can consider more features and the model will get more and more complex. The visualization will get complex. We'll move to 3D and 4D and multi-dimensional system as well. So yeah, that was pretty much all I needed to cover from this particular video. I hope you get the idea. I hope you get the intuition. Please follow us on the social media handles, and thank you very much for watching this video.